Okay, so let's try to run this. Okay, it's saying an error. Oh, uh, we have written MISC, or even if you write MISC.c, it will not work because this is just the name of the file. We have to give the entire location of where the file is. Okay, so this functionality or this directive was used when there was no compiler, because it was difficult to open up each file and check the contents of each of those files or those codes. So this directive was actually useful when you are working with a lot of files for a large project to debug the code actually. Okay, so what we have to do, we have to give the name or the location of the file. So instead of giving the entire location, I've just given this macro, because by default this macro already contains the location and the name of the file. Okay, so let's try to understand this before we run it. At first, the file name, then the line, time and date will be printed for this file, then the line number will be changed and the file name will also be changed. Okay, then it will again be printed. So we should see a difference between these two. Okay, so let's compare. At the very beginning it will print the name of the file. Okay, fine. Then line number 5, so this line is in line number 5, right? So it's printing line number 5, that's fine. Then the time, then the date. Okay, so then again the file is printed, the name of the file is same because we gave the same name as before, but now instead of line number 9, it's printing line number 3. It's supposed to be printing line number 9, right? Because the first print is done in line number 5, the second one is done in line number 9. So this should be line number 9. Why is it 3? Because we have changed the line to 2. Okay, so remember, whenever this line is changed, that means the next line that will be executed is line number 2, right? Not this line, but the next line which will be executed is line number 2. So now it was line number 7 and the next line to be executed was line number 8, but what happened, the variable was changed to 2. So instead of line number 8, it should show that line number 2 is being executed. So when line number 9 is being executed, it is supposed to show that line number 3 is being executed, which is exactly what it is showing, and the time and date is same as before. Okay, so let's continue with the slide. So we have seen the uses of these macros. Okay, so this is the end of the the preprocessor directives part, but some important things are here. The first thing is the C preprocessor directives are actually not a part of C. I've already told you, right? So they are something different, so they do not follow the syntax, which is why you already saw, right? We do not use any semicolon, which we use at the end of the C statements. Even in case of hash include, we do not use semicolon, right? Because they are not the same as normal C statements. Okay, they are special scripting language which is used in C. So what are scripting languages? So we'll see in the fourth line here. The third line is this language does not fall under C. Okay, so it does not fall under C token. So you cannot actually divide the words of the preprocessors into C tokens. So what is a scripting language? A scripting language is a language which does not need to be compiled. Okay, here's a mistake. It should be to be compiled, and it can directly be interpreted to binary language for execution. Okay, so if you remember, in case of compilation, we had what, a few levels, right? Then the .c file was eventually converted to an executable file, right? But in case of scripting languages, this compilation is not required. An interpreter can be used. Okay, so high level languages are compiled using a compiler, and scripts are interpreted using an interpreter. Okay, so I'll just show you sort of a simulation for you to understand. So what happens is, if you have a code which is in .c, that means a .c code, so this is converted or compiled using a compiler into an executable code or executable file which is a .exe file, okay, and the operating system uses the .exe file or executable file, okay. So this is in case of high level languages. So in case of C also the same thing happens, but when you are working with scripts or scripting language, so let's say we have a script here, so instead of a compiler, an interpreter is used, okay, and the operating system directly works with the interpreter or uses the interpreter to actually work with the script or execute the script, okay. So this is the difference between an interpreter and a compiler, and the difference between a script and a high level language, okay, or high level language code. So let's go back to our slide. So the next thing is common library functions, okay. So you already know some of the common functions like string functions, strcpy for string copy, string compare, etc., and math functions. So many other functions are actually available, and I will just talk about them. I will not explain all of them because there are many functions, and they're available in Appendix A, page number 412 of Teach Yourself C. So some of them are strtok or tok for string token, then strchr for string character, str for string string. So these are all functions to manipulate strings, to find substrings inside strings and this sort of thing, okay, or to divide the entire statement or sentence into words which are separated by spaces. So these things can be done using these functions. Then there are some math functions, okay. So string functions are in string.h, okay. So similarly math functions are in math.h, then time and date functions are time.h. So like this you can see all of those in the appendices, okay. So math functions are acos, which then assign, then ceil, floor, then this is for float absolute value, then exponent, then this is for log base 2, this is log base 10, etc. Then time and date functions are ASC time, which is required to find the time, then clock, then diff time is very important because if you find two time values, then you can find the difference in terms of seconds even. Then there are dynamic memory allocation functions, which we have already seen. Then there are some other functions like abort, then ASCII to float, then ASCII to integer, ASCII to long, then exit function, then random function, S1 we have seen that, then qsort, which is a sort of sort function, and binary search, etc. Okay. So the next thing is complexity. Okay, so this is a very important topic. Okay, so what is complexity? So in our case, actually, we can also call it computational complexity. So computational complexity, or simply complexity, is the amount of resources or the amount of things that are required to run a program. So based on those resources or things, complexity are of two types: space complexity and time complexity. So space complexity calculates or tells us the amount of memory required to execute the program, and time complexity gives us the time or amount of time spent or the execution time of the program. Okay, and based on the scenarios, again, complexities are of three types: best case complexity, which is when the program runs in the best situation, okay, and worst case complexity is when the scenario is the worst, and average case is the average of the both scenarios. Okay, so how come the same program have best, worst, and average cases, right? So let me just give you an example which is not related to code, but I guess from this you might understand. Okay, so let's say we have you, this is you here, okay, and this is your home, and you have to go home. Okay, pardon the bad drawing. So this is you and this is your home. Okay, so let's say this is the road which is the easiest. Okay, that means there is no traffic jam, nothing. And let's say this is another road which contains a lot of traffic jam and which is a longer road. Okay, I guess you can understand this easily because you have to go from IIT to home on a regular basis, or maybe you had to. So let's assume that the easier road or the shorter road requires 30 minutes for you to go home, okay, from IIT to home. And compared to that, let's say we have another path. Okay, so on a good day you can travel from IIT to home in 30 minutes. That means there is no traffic jam and the road is not blocked. Okay, compared to that, the other path requires 2 hours, so that is in a bad day. That means there is a lot of traffic jam, or maybe you have to take another road. Okay, so there are two types of ways through which you can go home, and obviously both of them will not be true or will not be applicable in the same day. Someday you might require 30 minutes, someday you might require 40 minutes or 50 minutes, and the maximum you might require is 2 hours. So in this case we can say that the best case is the 30-minute path and the worst case is the 2 hours path. But you can clearly understand that it's not so simple, because the time might vary largely between 30 minutes to 2 hours. Okay, so this is where the average case comes. Okay, so let's say 20 days. Okay, you have to travel home 20 days in a month. So out of those 10 days you require 30 minutes, just for simplicity I'm assuming this, and for the other 10 days you require 2 hours. Okay, so in this scenario the average case will be something in between 30 minutes and 2 hours, which should be what, the average of 30 or 2 hours. Okay, so you can understand that there are three different scenarios here: the best case, worst case, and the average case. And you will find these three scenarios in every aspect of life. Okay, the same goes for computers. Okay, I hope it was understandable. So based on the example that you saw, the programs also can run in the best case, worst case, and average case. Okay, so what we'll be seeing in these three types of complexities, we'll only be looking at complexities in general. Okay, so we'll not go or we'll not dive deep into complexities, because you will learn that in your later courses, maybe in discrete mathematics or data structure courses. So we'll just learn, we'll just understand the basic. So some basic complexities of worst case complexities, which is represented as a big O, are O1, On square, and O log n. Okay, so understand this, these are all worst case complexities. Okay, we are not working with best case and average case, so we are working with complexities in general. So instead of creating differences between the three complexities, we'll be only working with worst case complexity, which is represented as big of O. Okay, but for simplicity you can assume that this is any of those complexities. Okay, so O1 means the program runs in constant time. That means a fixed amount of time. So 1 is a constant, and if the program runs for a fixed amount of time, that means for let's say for 3 seconds, whatever the problem may be, the solution, the program always runs in 3 seconds. That means the program runs in a constant time. So On means the program runs linearly with respect to the variable n. Okay, so understand this, we are not working with space complexity, we are just looking at time complexity to understand how complexities work. So this is just in general. So On means the execution time increases linearly with respect to the variable n. So for example, let's say I have told you to find one person out of n people. Okay, so you have to search each and every person manually to understand whether this is the person that I'm looking for or not. So if the number of people increases, then more time is required to find that person. Okay, so something like that. On is something like that. On square means the execution time increases at the same rate as the square of the variable n. Okay, and O log n means the execution time increases with the logarithm of variable n. Okay, so I think you didn't understand all of that, but no need to panic, because we'll understand this with a few examples. For example, in this scenario we have to find out whether a number is prime or not. Okay, so we have an integer n, we have an integer prime equal to 1. So if prime is equal to 1, it means that the number n is a prime number, and if prime is equal to 0, it means that the number n is not a prime number. So the second line, we are scanning the number n, and then we are going through it using an integer I. Okay, so we are going from 2 to n by 2. So this is how actually we can find out whether a number is prime or not. We divide the prime number or the number with all the numbers before that prime number until 1. Okay, so that is what we are doing. We're dividing it by 2, then we are incrementing, dividing it by 3, then incrementing, and so on until I reaches the value n by 2. So if n mod I, that means if n divided by I gives a remainder, then we'll continue, because that means that it was not divisible. Otherwise prime will be equal to 0 and we will break. Okay, so this is just a prime finder. Okay, so now let's go into the complexity. So this line, the very first line, this will only be executed once, right? The second line will also be executed once. So we can say that both of these lines have complexity of O1 or constant time. Now this for loop, this will execute n by 2 times, right? The more the value of n is, the more times these lines will be executed, right? So the very first line will be executed of the for loop n by 2 times. Why? Because this will be executed once and this will be executed n by 2 minus 1 times. Is it clear? Because even at the very end, before breaking, we have to check whether we want to break here or not, or whether this condition is true or not, and then we'll break, right? So it will be executed n by 2 times at most. Remember, it might break even before n by 2 times, right? But we are working with worst time complexity. That means the worst case scenario. And the worst case scenario is what? The whole loop will be executed and we will not be able to break at all. So in that case, this line will be executed n by 2 times at most. Similarly, this line will be executed n by 2 minus 1 times at most. This one will be executed minus 1 times at most. And the break line will be executed only once, because once we break, the loop will not be executed. Okay, so in this way we can say that the complexity of the entire code is what? O of n by 2, right? And as 2 is a constant, we can say that the complexity of this whole program is O of n, or big O of n. Is it clear? So we can say that this first line is big O of 1, this line is big O of 1, and rest of all the lines are big O of n. Is it clear? So you might say that, okay, this should be executed one less time, right? But as 1 is a constant, we can ignore 1, okay, because that 1 will always be same, but this n will be changing. Okay, so these are the complexities of all the lines of this program. Okay, so like that, if we see another code here, so here I is equal to 0 and I less than n, so this will start looping from 0 to n minus 1. Then inside that, j will start from 0 to n minus 1. Inside that again, k equal to 0, k less than n, that means k to up to n minus 1. Okay, so the first line will be executed n times, and for each of those n times, the second line will be executed another n times, which is why the complexity of this line is big O of n square. And for each of those n square times, another n lines will be executed, right? So this hello will be printed actually n cube times, and this line will also be executed n cube times. Is it clear? So if it's not clear, you can ask questions, because we'll have a discussion based on this slide also. Okay, and the very last one is I starting from 0 to square root of n. So in this case, we can say that the worst case complexity is O log of n. Okay, because this log has a base of 2, and base of 2 means we are working with square roots. So this line will actually be executed square root of n times, or we can say that log of n times. Okay, so the last topic for this slide is programming practices. So I have seen a lot of you write code in many different ways, and it is very difficult for the teachers to debug it, and also for yourself to understand what you have written and why you have written it. So I'm going to just show you some practices or programming practices and end this slide and also the entire semester. So the very first thing is indentation. Always give proper indentation to indicate scope. Okay, so indentation means gap at the very beginning of a line. For example, this for loop, there is nothing before this for loop, so I did not give any gap before the for loop. But the next line, this if is inside the scope of the for loop, right? So always give a space before the if condition. This space is called indentation, and in compilers just giving tab will give an indentation. Okay, so after that give another indentation from the after this if. Okay, because this for is inside if, and then this printf is inside for. Okay, so give indentation whenever you are going inside a scope. Okay, and follow the latest C standard rules. For example, it is mandatory to use int and return 0 for main functions. Many of you might use void main, it might work. Then do not return any values, that also might work. But it is a standard to use int main and return 0, as the return type and values of main function are used by the operating system. And the third point is use logical names for variables. Our department heads are already told you that. For example, if you want to use a temporary variable, use the name temp as the identifier. Then it will be easier for you to and everyone else who reads your code to understand what this variable signifies. Okay, and always use comments and documentations. Okay, so this is for comments and these symbols are for documentation, because whenever you're working with large codes, you will forget yourself what each function is doing or what each code block is doing. Okay, and use functions to make the code modular when needed. So instead of making a huge code and all of it inside the main function, always try to create functions to use certain functionalities again and again instead of writing that code again and again. Okay, and use debugging procedures to check code frequently. For example, I already showed you one, which is printing using debug. Okay, so the next thing is standard template library. Okay, so this is something which is very, very important, but you might have already learned it in your programming classes, that is SCM programming classes, and again we will learn them later on also. So the libraries here are actually not part of C but part of C++. So we will not be working with them, but I'll just be showing you some of them, and you will also learn what they are in the later courses. So the structures, these data structures or containers are actually of two types: simple structures and complex structures. So I will just be showing you how the simple structures work, and the complex structures you will learn later on, and not in this course. Okay, so we already saw stack, so I'm just going to show you in short how vector, stack and queue, all of them work. Okay, don't become impatient, I'm going to end it here. So stack. So in case of stack, if you remember, if we place any item or any object inside the stack and afterwards we place another item, then another item, and keep on doing this, we cannot touch any other item without removing any item before it. For example, this blue one was inserted first, then the red one, then the green one, then the black one. Okay, so if you want to remove the green one, we have to at first remove the black one, then we can remove the green one. Is it clear? Otherwise we cannot remove it. Okay, so this is how it works. If you want to remove the blue one, we have to remove all of these, then we can move the blue one. Okay, so this is how a stack works. So next, if you want to insert again, we have to insert on top of what we have already removed. So we have removed the green one, so now if we add, it will be added on top of the red one. Okay, so now we have added another blue one and another black one. Okay, so this is how stack works. So next, let's see how queue works. Okay, so queues are exactly what the name suggests. If you see any queue or line for any shop or any, for example, in your cafeteria, so queues have certain rules. For example, the item here, the blue item here, this is the very first item. Okay, so afterwards, if any other item needs to be added, it can only be added behind or after the blue one. Then again, if I want to add, again after the red one. Okay, now if I want to remove something, I have to remove from the top. So this is just the opposite of stack when you are removing. So removing from the top, the blue one is removed, then again the red one. Now if you want to add something, again it will be added at the again added at the bottom, okay, not at the top. From the top you can only remove, and from the bottom you can only add, okay. So this is how it works. So these two have a separate name. So the name for stack is first in last out, because the first item that is inserted inside the stack is the last one to get out. And in case of queue, it is called first in first out, because the first one that gets in the queue is also the first one to leave the queue, okay. So this is how stack and queue work. Next we're going to see vector. So vector is just a variable array, nothing else. So it is just like a normal array. The only difference is you can add elements in the middle or remove elements from it, okay. So nothing new here. Whenever you want to add something in between, you have to move all of this to the top or all of this to the bottom to insert something in between, okay. So it works just like arrays, but it is much easier to handle compared to arrays, okay. So this was the last thing for this semester, I guess. So I am going to end my class here for the whole semester, and we'll still be having discussion classes, but this is the end of my official presentation or lecture videos. So may Allah bless you with knowledge and hidayah. Assalamu alaikum, and thank you very much.